Want to make an app that displays current, up-to-date information like this one? It's all done with APIs. What is an API? That's today on Code Lab. Hello and welcome to Code Lab. I'm Mark. Today, we're going to be building an app that gets the current conditions for any location in the US. The application automatically detects the user's location and then uses that information to get the current weather conditions from the OpenWeatherMap API. The folks who run the OpenWeatherMap API are kind enough to have a free level of service, which is what we're using today. Apps very similar to the one we're building today are used to display weather information, sports scores, and stock market quotes for television, digital signage, and other channels where up-to-date information is critical. This app is built using HTML and JavaScript, although we could use the OpenWeatherMap API with almost any coding language. We're going to go through the code line by line. As we do, pay attention to the big picture skills here, communicating with an API in JavaScript, and parsing the JSON response that the OpenWeatherMap API server provides. We'll start with a demo of the application itself. Before we jump into our demo, don't forget to like this video and subscribe to our channel. We're bringing you new career-building skills in coding, digital design, and cloud productivity each week. You can also visit our website with skill-building courses at techlearningnetwork.com. And here you can see our application running. The application has determined our current position, which is in Westport, Connecticut, and provided the current weather conditions. As I record this, it's a hot summer day, so it's 84 degrees outside, but it feels like 86. Today's high will be 88 and the low 78. Wind from the south-southwest at 4 miles an hour. Sunrise was at 5:26 this morning. I know because I was awake. And sunset will be at 8:29 p.m. Just to make this more interesting, we're going to go ahead and test a separate location. So from this dropdown, I'm going to select Portland. I've already programmed in the latitude and longitude. And now I'll refresh. And there you can see we have the conditions for York Harbor, which is part of Portland, Maine. In Portland, it's only 67 degrees. A little cooler in Portland, Maine than it is in Connecticut. All right, but now you see how the application works, or at least what it does. Now, let's go over the code that makes all this happen and see how this API communication takes place. All right, so here is the code, and I've actually written this in two separate documents. We have our index.html, which contains the HTML, and then towards the bottom of the document, all of our JavaScript. There's quite a bit of JavaScript that makes this happen, but the JavaScript is actually pretty straightforward. The styling came from weather.css. Just about 6 or 7 styles here made all this happen and made it display the way that you see. Let's start with the HTML, which is relatively simple. Of course, the first part of our HTML is the head of our document, and this contains meta information about the document itself, and also connections to other libraries that we may be using, like our CSS. So you can see we have meta tags on lines 4, 5, and 6, which just gives some information about our HTML document. We're using the UTF character set. We have our viewport, so it measures the same as the user's screen. And on line 7, we're linking to the CSS file I showed you a moment ago. That contains all of our style information. That takes care of the head of our document, so now we'll go down to the body. The body of our document is where everything that appears on the screen is going to be placed. Now, our body is fairly simple. There's actually only one logical division in there. And that's because we're creating all the content dynamically. We don't know what we're going to display until we communicate with the OpenWeatherMap API server. So our body is relatively short. And there you can see our body starts on line 10 and ends on line 13. We simply have the division, which I've ID'd as weather. That division will be filled in later with the information that comes from our server. And now the part you've all been waiting for, our JavaScript. The JavaScript, of course, is where all the dynamic processing takes place. It's where we're going to communicate with the OpenWeatherMap API server and where we're going to parse the result that comes back. In order to follow along with me, you're going to want to get your own OpenWeatherMap API account. It's free. Just go to openweathermap.org. And you can click a drop-down over here. Since I'm logged in, it has my drop-down, but you'll be able to get your own profile here. And in just a few minutes, you'll get your own API key. You'll notice my API keys are here. Now, I'm going to erase these keys after I record this, so you won't be able to reuse my keys. But you'll be able to get your own key. I just copied it and then pasted it into this variable called key on line 15. On line 16, we have the URL for the OpenWeatherMap API. Looks pretty much like any other URL you've dealt with. We're actually going to add some data to it once we determine our user location. I'm going to skip the convert time function and the K to F function, as well as the wind direction function for right now. These are functions we'll actually use later when we want to display our data. We don't have any data yet, so that's why we need this next function that's going to determine our location. So the first thing that actually happens is we get our user's latitude and longitude. That occurs with the navigator.glocation.getCurrentPosition function. This is a built-in JavaScript function that's designed to get our user's latitude and longitude. We get the latitude by accessing position.chords.latitude, and we get the longitude by accessing position.chords.longitude. Those are built in and active once you've run the getCurrentPosition function. I've set those to local variables called lat and long. On line 74, notice I'm adding to the URL, that URL that communicated with the OpenWeatherMap API, and I'm creating a query string that provides the latitude, the longitude, and that API key. So that goes at the end of the actual URL. Let's see how this works. What I'm going to do is I'm going to use console.log to log out the URL. So once we create the URL, I'm going to log it. Let's try it. And I'll find that log if I go to my three dots in the upper right-hand corner, More Tools, and Developer Tools, and then go to Console. And right here is the actual URL we created. So I'm going to go ahead and copy that URL right here with copy link address. I'm going to open a new tab, and I'm just going to paste that URL that we created. You can see in there the latitude, the longitude, and our app ID. And if I send that directly through our browser, you'll notice that this data comes back. Let's make that a little bigger. And if you look carefully, you can see what looks like a weather report in there. There's temperature, the feels like temperature, the temperature minimum, temperature maximum, the pressure, the humidity. I actually didn't use all this information in the app. I could have given a more detailed report based on this API, but it starts to get repetitive since every detail is accessed the same way. Notice we have the sunrise and sunset. So this is the string that comes back. This is called JSON, JavaScript Object Notation. So this is processed by my code once it's returned to the browser. So we've made that URL. And on line 77 is where we communicate with the server using the fetch command. We fetch the URL, which again has the URL for OpenWeatherMap API, the latitude and longitude, which we've obtained through the position object, and our API key. We then take that response on line 78, whatever comes back, and we convert that to our JavaScript object notation from the string that's returned. The reason we use fetch is we don't know how long it's going to take the server to respond when we query it. So because we don't know how long, we essentially ask our program to wait with the fetch command. That's why it's fetch then. Once the server responds, then we run the then clause. So once we get the response, we convert it to JSON. Then we take all that data on line 82, you saw the string that comes back, and we send it to the display weather function, which starts on line 86. Here in our developer tools, we're looking at the parsed version of that string that comes back, and I can actually click through and see all the data. You'll notice that each piece of data is paired with a label. Humidity 51, pressure 1015, temp 302.1. By the way, these temperatures are Kelvin temperatures. It's not 300 degrees here, at least not 300 degrees Fahrenheit. So the way we can access this data is by the labels. We'll access the labels like feels like, temperature, temp max, in order to get the data out of this object that's been returned. And you can see that's what we're doing in lines 87 through 96. We're getting the city from weather.name. If you look about 2/3 of the way down our JSON, you can see name Westport. So we're getting the data Westport from city.name, and using weather.name in line 87, we're storing a local variable called city. We're repeating that process for sunrise, sunset, temperature, etc. Now you'll notice we got city from just weather.name. We got sunrise from weather.sys.sunrise. Here's why. Notice to get to sunrise, the whole object is called weather. We go into SYS, and there's sunrise. So we're just following this object like a map to get to our data. You'll notice wind is another object, and we can get degrees and speed from wind. Likewise, on line 95 and 96, we get weather.wind.deg for degrees and weather.wind.speed. Okay, so now that we've run this, all of our data is held in these local variables. Now we're going to go ahead and create our actual display from the data we've been able to extract from the JSON that came from the OpenWeatherMap API. So I've created this giant variable called output. And output takes all of the information that's been returned and set to local variables, and it puts it into a string of HTML. So notice our output starts with an H1, the city, the text current conditions, and we close the H1. And you can see the result at the top of the browser window. There it says Westport current conditions. The next part of our output is that big temperature, and that's created by line 100. We add to the output a logical division that says conditions, and in there we have an H2, and we run a function K2F on the value current temperature. The ampersand hash sign 8457 simply displays the little degrees symbol and Fahrenheit. What is K to F? Well, the K to F function is where we're converting from Kelvin to Fahrenheit. Don't forget our API returns a Kelvin temperature, but the human beings want to see Fahrenheit or Celsius. So on line 28 is our K to F, or Kelvin to Fahrenheit utility function. All it does is it does the conversion math, 1.8 times Kelvin temperature minus 273 plus 32, and returns the Fahrenheit value. Quick utility to give us the number that the human beings will understand. We follow that process for the feels like temperature. Notice it's K to F, feels like, and we wrap that in an H3 with the label feels like. Also high today and low today. Again, same process. Send the value to the K to F function, and then use that value in our actual display. And there you can see we get these human readable temperatures in Fahrenheit. Feels like 86 degrees Fahrenheit, high today's 88, low today 78. We still have some more data that we need to parse. Starting on line 104, we have the wind direction. Now, the wind direction we send to the wind direction function. And that's because the wind direction comes as a value between 0 and 360. It gives us the degrees of wind. But generally, people want to see something like north, south, etc. So the wind direction function, which starts on line 34, takes that value, and it converts the value to north by northeast, or NE, or east-northeast, or east. So all it's taking is the simple value and returning a direction. So for example, if the value was 90, meaning our wind was easterly, that's going to be detected by line 41. In line 41, if the value is between 78.75 and 101.25, we return an E. Our wind was south-southwest. And we can actually see the value 210 if we look at the object that's been parsed in the right-hand side. See degrees 210? So that translated to south southwest. We can go down and see on line 51, our value was between 191.25 and 213.75, so south-southwest was returned. In addition to the wind direction in mile per hour, which just needed to be rounded on line 104, did not need to be converted, we have the sunrise and sunset times as part of our display. Of course, they wouldn't make this easy. Our API returns what's called Unix epoch time. That's the number of seconds since the Unix epoch date, which was January 1st, 1970 at midnight. Were you alive? I wasn't. I'm not that old. If you look towards the bottom in the sys object, you've got the sunrise and sunset values. Those are the Unix epoch values. We needed to convert those into, again, something that human beings could read. Sunrise at 5:26 a.m., sunset at 8:29 p.m. We had a utility function for this as well on line 19, the convert time function. That takes that Unix epoch and creates a JavaScript date object. You'll notice I'm multiplying that epoch time by 1,000, and that's because JavaScript deals in milliseconds, not seconds. From the new object we've created on line 20, I can get the hours, I can get the AM, PM, and the minutes. I'm doing some formatting here where, for example, AM, PM, if the hours is greater than or equal to 12, then it's PM, otherwise it's AM. With the minutes, if the minutes is less than 10, I'm going to prepend the minutes with a 0, right? Because we display, for example, 808 as 8:08, or 809, 8:09. So that adds the 0 to make our display look correct when the times are less than 10 minutes. If the time is not less than 10 minutes, we leave it alone, and we simply display what we get from date.getMinutes. The time variable on line 24 takes the hours, adds a colon, takes the minutes, adds the AM and PM, and then returns the human readable time. So you'll notice we use convert time on lines 106 and 107 to get the time that's human readable by setting it the sunrise and then the sunset time. We then close up all of our divs, and line 109 takes this long HTML output variable that we just created and puts it in document.getElementById.weather. It's been a while, so you might have forgotten what that is. Let's take a look at the HTML again. Here in the body, on line 11 is our div weather. So essentially, we're taking all that HTML and putting it in there, which creates our display. There's our display created by HTML. But there's one more thing we have to look at, and that's the CSS that actually makes the display look the way it looks. This is obviously not the default display that HTML would display if we didn't have any CSS. So I wanted to keep this pretty simple. Our body has a blue background color. The font that we chose first was Geneva. If the user doesn't have Geneva, we'll use Verdana. The color of all our text is white. For the conditions section, we have a 2-pixel solid white border all the way around it with a padding of 20. You can see that border all around the area where it says 84 degrees and has all our conditions. The H1, where we have our city, also has the 2-pixel solid white border, a font size of 3M. 3M essentially means 300% of whatever the user has chosen as normal, and we're aligning our text to the center. The temperature is displayed in a heading 2 tag, which is 14 times the size of our normal text, aligned to the center, and we have a little margin at the top and bottom. That's the 84 degrees Fahrenheit. That's our H2, 14 times the size of standard text. The rest of our content is displayed in an H3, font size 2¼ times normal, margin at the top and bottom. The 2 boxes at the bottom, we have a temperature box and a wind box, have a 1-pixel solid white border with a padding of 20. You can see the 1-pixel solid white border around the feels like area and the wind area. The padding is what gives us space between the line and the actual text. Finally, our detail area is both boxes. The flex display in flex direction row and justify content center is what gives us the 2 boxes next to each other and centered within the overall display. So there you have it. This is a fairly straightforward program. Our body just has the blank div. That's populated by our script, which first creates the URL on lines 15 and 16. On line 71, gets the user's geolocation, latitude and longitude, completes the URL with that information, On line 77, communicates with the API by sending the whole URL, which includes the actual address for OpenWeatherMap API, latitude, longitude, and the key. Takes that JSON response, extracts out the data that we want, the city, the sunrise, the sunset, etc. Creates HTML encapsulating all that data in a display. On line 109, places that display in our actual document, with all of our data being styled by our CSS. Thank you so much for watching. I hope you enjoyed working through this project with me. If you're new to JavaScript coding, I hope this episode of Code Lab gave you a sense of what's possible. And if you're already starting to code in JavaScript, I hope you're more comfortable with these new skills: communicating with an API and parsing JSON results. I'm Mark for Code Lab. Thanks for watching. We'll see you next time.